This is problem number 5. The deal here is that in a problem, you can have written 750 kilonewtons per meter or per foot is not important, or you could have written the total weight. Well, 750 kilonewtons per meter or 1000 kilonewtons per meter, if we understand here, I don't know why the numbers are not, but you can look in the next diagram that the numbers are 8 plus 10, okay? 750 multiplied by 8 and 10,000 multiplied by 10 is exactly the same than this one. That happens to be one of the exercises of the book. You see, the 750 multiplied by 8 is 6,000. 1,000 multiplied by 10 is 10,000. Well, in one of them is 7,050 per feet, in the other is 6,000 pounds. It should be the same. If we forgot about the units, obviously, the number is the same. Well, you need to be very careful if in your exercises written pounds or not. In order to eliminate that problem in the test, you will always have pounds per foot, always. You will always need to multiply. Is that clear?
Yes.
Even in the instructions is written. I will recommend you when you look at the test, read instructions. I know that you already know instruction. I know that you need to leave 2 decimals or you don't need to write pounds or whatever is the unit, but you must read it because you can forget in that moment and don't multiply. And then your problem is completely wrong. Well, this problem, sorry, let's go up again, is exactly the same. Well, you have here the problem made with CAD, like this is perfect, because you know, I don't want some students, like the student that was here, UL, the complainer, to tell me, professor, something was wrong in the drawing, and that's why I did wrong in the test. Well, to eliminate that kind of dealing, to don't deal with that, I have something that is calculated there with CAD with 3 decimals that is exact. But yours will not be that exact. Yours will be more like this, okay? And the calculation is there.
Mm-hmm.
Well, look what happens. You start making again the same diagram that you had before, but with the new weights. I will substitute 6,000 by a 6,000 number that is located exactly here. Let me move this because I will record this and I will need to change. I will need to cut the part where I spoke about that student. I will just want to remember where I do it. Okay, now I will understand where I was. Okay, I will start with the problem number 5. As I told you, there are 2 ways to make the drawing of this particular problem. One is the one that is here, is made with CAD, and it will be like in the test, and it's written, oh, sorry, and it's written here, 750 kilonewtons per meter or 1,000 kilonewtons per meter. I will change this by pounds because somebody may complain. That is the same that have the total weight here, okay? In the book, you will have kilonewtons and you will also have pounds because this is an international book and you have meters there. Well, what we will do, you take 6,000 and you substitute 6,000 by a line here in the center of 8, the center is 4, you will put 6,000. By coincidence, in the same place, you have another line of 3,000. Well, you put them together and you have 9,000, okay? After, you will substitute this load in red, that is 10,000, 1,000 per feet, for one in the middle, there. But you don't draw that there, you draw it in a different one to don't get confused. In my case, it's very easy to erase, but you don't want to make your test a little bit messy. Those are the only two forces that you have. After you have two reactions, reaction 1 and reaction 2. You start doing the calculations, and the calculations are as follows. R1 multiplied by 0 is 0. 9,000 multiplied by the distance to separate is 4. 10,000 by the distance is 13. R2 by the distance is 14. R2 is positive because I wanted. I choose is positive. Therefore, R1 is positive, what is not a deal because it's 0. Therefore, 9,000 and 1,000 that are going down are negative. I calculate how much is R1. I do the same and I calculate how much is R2. I put them together, and then together they need to be equal to 19,000. 11,857 plus 7,142, 86 need to be equal to 19,000. If not, you did a mistake. What other mistake you can do when you do the calculations? This is a typical mistake that students do. They write here summatory of moments in R1 equal to R1, and after they write R1 equal to 11,000. No, when you calculate the moment in R1, you get the result of R2. Well, this is R2, 11,000 will be here in R2. Got it? That is a typical mistake.
Yeah,
After you have your
made that
two
mistake before.
reactions correct, and you realize that it's correct, you just go in your head and imagine for one moment this being, this one, not the original, this one is easier. You imagine this being here, and you tell yourself, if I have 9,000 there, and I have 10,000 there, and I have a guy that is called R1, and I have a guy that is called R2, who is taking more weight? I mean, I am telling you to imagine, like for example, let me move here. Imagine that you have a refrigerator. The refrigerator have a motor in the inferior part. If you need to carry this refrigerator, you will do like this. You will put the refrigerator horizontal. One person will be carrying this, and another person will be carrying this one. You see? The motor is there. Who is taking more weight? Mr. A or Mr. B? That's the
We'll
motor.
assume Mr. B, right?
Obviously, because Mr. B is in the side where is the motor.
Right.
Well, here is the same. Look, if you have somebody here taking that beam, that column, and somebody here taking that column, this column has an area there without any weight, have 10,000 very near, separated 1, and this guy instead have 9,000 separated 4. It's obvious that R2 is bigger. Guys, R2 is bigger there.
Yes.
Well, you can do that experiment in a moment to realize that the reactions are good. It's very important that the reactions are good, because if not, everything will be wrong. Let's continue. After we have the reactions, we will start calculating how much are the different forces. I make a line where the beam finish. I make a line where the beam start or finish. I make a line every time that something happens. Here there is a force, because remember, we forgot about this diagram. Now we work with this one. Here, this force changed. Look, it was 6 and became 10. Well, I need this line. Here, we have a reaction. I need this line. Here, the beam finish. I know that the answer here is 0. I mean, I will plot 0. I will start in 0. I know that here is 0. I just need 1, 2, and 3 numbers. It's not that complicated. Okay? Well, I'm sorry, because reaction 1 is 7,000 and is in that particular point. From 0, we'll move up. But we already have that number we calculate. Well, we only need to calculate 3. Let me clean everything. And look what I do. I tell myself, from 0, I go 7,000. It's like going to the bank. You imagine that you are an ant, a little insect, and you are walking in this bin and you're looking what happens. You are in the ant, nothing happens before, but you receive a force R1, and immediately you start receiving this reaction. R1 is going up. It's like a positive bill, like money that you receive it, you go up. Let me change my marker. You go up from 0, 7,000. After you have this part of the diagram, you need to cut the bin there because this line is there. Well, this part of the diagram is 6,000 divided by 2. Why by 2? Because it's 4 plus 4. This weight is half of the weight of 6,000. It's 3,000. Well, you go down 3,000 because it's going down. And you arrive to 7,000 minus 3,000. You arrive to this number. And that is the number that you have here. Next, there is a force over there that I don't know how much it is. Let me move. No, there is no force. We still have that rest of the triangle, of the rectangle that is also 3,000. We have the next 3,000, this one here in black. Well, I need to go down 3,000. 4,000 minus 3,000, I go down. Next, we have an inclined, no, sorry, we have the reaction, I apologize. We have this one, 3,000, I apologize. We go down 3,000, by coincidence, it's the same. Okay, we go down 3,000. After we have this part that is also 3,000. Well, we go down 3,000. Here, it's the same number. This time is inclined. And we arrive to 1,800. Then we have 1,800 and we have all this area here. This is 10,000, the total, but is divided in 10 parts. And the first part that I will put in a different color, in green, this part in green, have a value of 6,000. Why? Because it's 1,000 per feet. That's why I don't like to put 10,000, I want to put by feet. Like this, you realize how it is. 1,000 per feet multiplied by 6 is 6,000. Well, I need to go down 6,000. And I go down 6,000. Arrive to 7,000 minus 6,000, 7,851. After I have a reaction of 1, this is the calculation, I go up. And after I have a last one, this is the calculation, I go down and finish at 0. It's not complicated. And you have all the operations for the shear in this side. Next, you need to calculate the areas. To calculate the areas, with one exception, will be very easy. You have all the areas calculated here. In one of the problems of the test, you will have inclined lines that do not cut, so do not pass the line 0. Will be easy to calculate those areas, and I imagine everybody will do that very easy. But in one of the questions, you may have this kind of elements where you have again the problem of the triangle. A triangle that is positive, that I will put here in red color, and a triangle that is negative, that I will draw here in brown color. And this line is new. And it's very important because it's the line of the maximum moment. Every time that the shear passes to 0, remember, it's the maximum moment. Well, how do you calculate those triangles? Well, again, the law of the similar triangles. Look, in pink, I will draw a triangle. 1, 2, and 3. I know that triangle because I know this distance and I know this distance. This distance over there is, let me go back. Was 4, is 4464. Remind me, please. 4464. That distance is 4. And speaking about the distance in green, this one is 4. And the other distance, we also have it because we have this number, 1142, that is distance here again in light blue. Sorry. Blue. We have this one. And we also have this number, 1857, that is this element. When we put them together, what number we get? 3000. Well, we have a triangle of 3000 here and 4 there. That triangle that is the same, that this one are identical, that the two blue triangles are similar to the small ones. Well, I just need to do the same calculation that I did before. If I have a base, if I have a side, and that's it. Got it?
Yes, you use basically like
3000.
the other values around the
Yes.
triangles, and then you use the
3000
proportions.
exactly is 4, then whatever the one that I want, the small one, 1100, whatever, 180, 57, whatever, is equal to, you multiply, you divide. That's it. After you have this area, this area, this area, these other areas that are easy to calculate, like this is 4000 by whatever, divide by 2. You have the calculations there, and you just need to plot. All this element is positive, you go up, growing fast, and after slow. You arrive here. After, in the same way, growing fast and slow, you arrive to the maximum moment, that will be this number. After you go down a little bit, and in this case, it's growing